All right, so we are on to inductors, the next type of component that we need to introduce, the last type of component really that we need to introduce in this class in order to analyze circuits and specifically first order circuits like we're talking about in this this module. I talked about capacitors. We went through RC circuits, how to solve them, how to look at charging and discharging capacitors, and now we're going to do pretty much a similar analysis on inductors. Inductors behave as a complementary component to capacitors, and so let me just get right into explaining what an inductor is. Okay, and so similarly to how I explained what a capacitor was, I have a picture here to show you what an inductor looks like and what is an inductor. So let me go ahead and grab my highlighter. So an inductor is a conductor. Sorry for all the words that sound the same. It's a conductor that is wound or wrapped around a magnetic core. The core does not need to be a physical material, similarly to the capacitor, where we had in the picture for the capacitor, you know, we had a plate. I drew some plate, and then I drew another plate and another, and then this central area here that's between the two plates can be, it can just be air, or it can be some other better dielectric to make the capacitor even better, or larger valued. Better would be a better word. For an inductor, the case is exactly the same. I can wrap my wire around air, and then that would be known as an air core inductor, or I can wrap it around some magnetic material, which would make it a quote-unquote better inductor, or have a higher value of inductance for the same size inductor. But literally all it is it's a wire or a conductor wrapped around some magnetic core. You could wrap a piece of wire around a pencil and spiral it in this fashion, and you would have an inductor. Okay, the symbol for an inductor, as you could probably pick from the schematic, or sorry, from the diagram that I drew, it looks like this. Not to be confused with the resistor, which is meant to look more zigzaggy and sharp than the inductor. The inductor has these loops. Sometimes you'll see it drawn like this. Sometimes you'll see it drawn more obviously rounded. Sometimes you'll see it drawn purposefully coiled like this. Not as often, but I think this is probably the most common here. So the first point here, I just wanted to mention that the conductor wound around the magnetic core is really the definition of the inductor. The second thing here is that, differently from capacitors, an inductor stores its energy in the form of magnetic fields. Okay, so I'm showing the magnetic fields here. The magnetic field lines would go out and around this, the space around this inductor, just like this. This is basically a magnet. It's an electromagnet when it has current flowing through it. So if there's current flowing in this wire, you know, around and then out the bottom, there would be an associated magnetic field with that current flowing. And so the energy storage in the inductor depends directly on whether or not we have current actually flowing in that inductor. Okay, and so we'll talk about that a little bit more when we get into RL circuits. But just note that we talked about capacitors storing energy in the form of electric fields. Well, now we're looking at inductors, and they store their energy in the form of a magnetic field. Okay, and the last little concept here for the inductor is that it behaves like a short in DC circuits. Okay, so capacitors behave like an open, which means no current flows through them at DC, and for an inductor, it behaves like a short in DC circuits, which means it has no voltage across it. Okay, so it basically just behaves like a wire, because it is a wire. I mean, quite literally, it's a wire. And so if I have a circuit and I have an inductor here, and sorry, let me make this a current source. If I have a current source here, say 1 milliamp or something is flowing through my inductor, for a resistor, we know that there has to be some voltage drop associated with that current that's flowing, right? Because V is equal to IR. If we have some resistance and some current, then we definitely would have some voltage drop across the resistor. But this is not a resistor, this is an inductor. Okay, and so let me just complete the circuit here. My inductor behaves like a short in DC circuits, so this inductor basically just looks like a wire, the voltage here, let's call it Vx, would be exactly the same as the voltage here. So in this case, because this is grounded, this would be 0 volts, and this would also be 0 volts, okay? And so it seems pretty strange that that could be the case, but that is 100% the case for inductors at DC, okay? So I'm going to wrap this video up right here, and in the next video, I'll talk a little bit more about the parameters that set the inductance, which is what we use to characterize, or the metric we use to measure how an inductor stores energy.